tan-chord theorem. Learners, this is a very important theorem, and even in grade 12, you can see this theorem is there in the exam. Okay, that is a tan-chord theorem. What is that tan-chord theorem saying here? The angle between a tangent to a circle and a chord drawn from the point of contact are equal to the angles in the alternate segment. Okay, so before we do this theorem, you need to know what you mean by a tangent. Tangent is a line that touch only one point, like this. It's like this. It touch only one point. Okay, so if I name the point of contact of tangent and the circle is P. Okay, if the line crosses circle, then it's going to be secant. Okay, the tangent means it touch only one point, like this. See, touch only one point. These are the tangents. One point. Okay, yes. And before we do this theorem, learners, you need to know always from the center, if you draw a radius to the point of contact, that always make 90 degree, like this. It's 90 degree. Okay, the tangent and the radius at the point of contact is always 90 degree. That you need to know. Okay, that is a very important result. The tangent and the radius at the point of radius or diameter at the point of contact, because isn't it diameter is 2 times radius, is always making 90 degree, or they are perpendicular. Okay, that don't forget, it's very important. So you can see a tangent there. Then what is that? The angle between tangent to a circle and a chord. Let me draw a chord here from P to chord is what? The line joining 2 points. One point is P, the other point, let me write it A. Okay, so AP is a chord. And where is the angle? See, did you see the angle here? This is the angle between tangent and chord. Okay, which is equal to the angle subtended by the same chord in the alternate segment. So here, where is the angle? This angle is part of the minor segment. So alternate segment means the other side, that is somewhere here. Let me call this one B. So the chord is subtending angle on the circumference, means there is a line that is coming from P and A going to join at B, like this. P and A, from B to A. You see that? Okay, this angle, this is the angle subtended by the chord. We can see the chord from P and A. The line is, 2 lines are going to the circle and meeting at B. See that this is what is known as angle subtension. So here, what we have to prove angle. Let me call the tangent PT. Okay, CPT. So C angle APT is equal to angle PBA. Okay, those 2 angles that you can see, that this angle P is equal to this angle B. If you can prove that, then we are done. So here, what are the given items? The tangent, under the given part is tangent CPT or PT. The tangent PT is there, and the chord what? Chord AP also there. AP there, and the angle B also given, isn't it? A circle with the center O, and these are the, let me put the center somewhere here, approximately center O. Right, so these are the things given. The tangent is there, then the chord AP is there, then the angle B also there. The B is made by that chord AP. I think you understood. So now you have to prove that. What do you want to prove? Let me want to prove the angle APT. Did you see that angle APT is equal to angle PBA? PBA. BA. You have to prove this one. If you can prove that, then tan-chord theorem, it is a very important theorem. Okay, so for that you have to construct a diameter from P, from the point of contact P, then you have to draw a diameter. It has to pass through the center and touch it. See, okay, let me call this point is C. Okay, now you can join from C to A or C to B. Both will give you the answer. Okay, here I am joining from joining the line from C to A like this. C to A diameter. Okay, all right, so the diameter PC and the line CA, so those are the construct you have to construct. So the under construction part, construct what? Diameter PC and the line CA and CA. Okay, the line CA. Let me write the line CA. Line CA. Yes. Now let me call the angles. So we can see angle APT, and let me call it P1, and this angle is P2. Okay. Yes. Then all right, that's it. So did you see that P1 plus P2 is 90 degree, isn't it? P1 plus P2 is 9, because that is the angle between this tangent and this, what, the diameter, isn't it? Is always 90. This one I'm talking about, 90 degree. That is proof. P1, angle P1 is plus P2 is equal to 90 degrees. What is the reason? It is the diameter is always, or radius is always perpendicular to a tangent. I told you already. That is diameter is perpendicular to tangent. Okay, now just to show that at the end you have to get what? P1, because I name it P1. APT become P1 now, isn't it? You can see there from the diagram. So show that P1 is equal to B, then we are done. So P1 plus P2 is equal to 90. The reason is diameter perpendicular to tangent. Okay. Now, guys, do you know that the full A, this A is 90 degree? How? Because that is the angle subtended by the diameter. Diameter is always subtending angle 90 degree, or angles in the semicircle is always 90 degree, isn't it? So which means, so let me write angle A, the complete angle A is equal to 90. Reason is the angle subtended by the diameter, isn't it? Or angle in semicircle. Angle in semicircle. Isn't it? Diameter is always subtending 90 degrees. So the full A is 90 degree, which means P2 plus C is also 90 degree, isn't it? Because those are the complementary angles, P2 and C. Because it's a right angle triangle, A is 90 degree means P2 and C in the very same right angle triangle, they are complementary angles. Complementary angles means their sum is 90. Then only the total sum going to be 180, isn't it? That is C plus P2 plus A is going to be 180. You know that angles in a triangle is, sum of the angles is always 180 degree, where one of them is 90 degree already. That is angle A is 90 degree, which means P2 plus angle C is equal to 90 degree, isn't it? Because angle A is equal to 90 degree, isn't it? Or sum of the angles in a triangle is equal to 180 degree, isn't it? Okay. All right. So look at these two equations. P1 plus P2 is equal to 90. P2 plus C also 90 degree. So the right hand side is same, which means left hand side, that is P1 plus P2 is equal to P2 plus C. Do you agree that? Okay, because the left hand side of those two equations also equal, because right hand sides are equal. Now P1 is equal to what, guys? P1 is equal to, send to P2 other side, that is P2 plus C minus P2, isn't it? So P2 cancel, so P1 is equal to angle C. We need to show what? P1 is equal to B, but we got what? P1, that is this angle P1 is equal to C. We got it, isn't it? All right, now look at the C and B. Are they same? C and B are the, yes, C and B, they are same because both are coming from the same chord, isn't it? The angles subtended by the chord AP, or angles in the same segment. Do you agree that? Okay, so angle C is equal to angle B, angles in the same segment, isn't it? Angles in the same segment. Or you can say that angle subtended by the same chord PA. Do you agree that? We can see that, look at the chord PA. This PA is subtending angle C, isn't it? And angle B also. Do you see that? So those two angles are same. Angles subtended by the same chord, or angles in the same segment. So P1 is equal to C and C is equal to B, which means P1 is equal to what? P1 is equal to B. So we are done. That we are looking for angle P1, which is same as APT, or we can write it, therefore APT is equal to PBA. So we are done. This is the tan-chord theorem. Example number 1, you can see a diagram. They said that SPT is a tangent. Learners, in any diagram, if you see a tangent there, then you have to think about the tan-chord theorem. Okay, that is very important, tangent and chord. So when you look at the tan-chord theorem, did you see the tangent SPT? Did you see the angle, this angle, sorry. Look at this angle. This angle is equal to this. This is a tan-chord theorem because P1 is the angle between tangent and chord PB, isn't it? And PB is subtending Y. And when you look at from right to left, you can see that angle X, also angle between tangent and chord, is what? PA, isn't it? This chord, PA. And PA is subtending what? 51, which means angle X, because you have to prove, you have to find what? The value of X, Y, Z. We got it. X is equal to 51 degree. Reason is tan-chord theorem. Tan-chord theorem. You have to write these three words, tan-chord theorem. Okay, this is how you have to write. X is equal to 51, which is tan-chord theorem. Clear? All right. Now we can, because we know the value of X is 51, isn't it? All right. Now it is given that parallel lines are there. What is that? BA is parallel to, which means Y and X, they are alternate angles, isn't it? So Y also equal to 51. Y is equal to 51 degree. Reason is alternate angles of a parallel lines. So what are the parallel lines here? BA is parallel to ST. So whenever you use the idea of parallel lines, you have to indicate the parallel lines there, whether it is alternate angle or corresponding angle or co-interior angle. You have to mention those parallel lines like the way I wrote it there. So we have X and we have Y. Now we have to look for Z, isn't it? So Y value is also 51 degree. So how do you find the value of Z? Z we can find out because in a triangle, other two angles are available, isn't it? So both of them are same, which means that triangle is an isosceles triangle. Okay, so we can find Z is equal to what? 1. We can sum of the angles in a triangle, isn't it? That is z plus 51 degree plus 51 degree is equal to 180. Reason is angle sum of angles in a triangle, isn't it? Now easily we can find the value of z, that is z plus 51 is 102 is equal to 180 degree. Therefore z is equal to 180 degree minus 102. So which is going to be, what is the answer? 78 degree. So we got it. So tan-chord theorem is there, parallel lines idea is there, then sum of the angles in a triangle also there. So that's how we got it. So mainly I'm showing here how to use tan-chord theorem. Let's do another question, example number 2. PBT is a tangent. Did you see that BPT is a tangent, isn't it? At a P. Okay, I can see that. Then some angles are given. RPT. Where is RPT? That is this angle. This angle is what? 60 degree. Isn't it? So that is the angle between tangent and chord PR, isn't it? Chord PR. So chord PR is subtending X. Okay, they want the angle in the alternate side. Don't take a S, is wrong. Okay, S and P, they are in the same segment. They want the angle in the opposite, that is X is equal to 60, isn't it? So we got the first value, X is equal to 60 degree. What is the reason? Tan-chord theorem. Tan-chord theorem. I hope you understood what is tan-chord theorem. So we got the value of X, isn't it? Is equal to 60. So something else is given. P3 also given 70. That is this one, 70. That is also an angle between tangent BPT and the chord what? QP, isn't it? This chord is subtending which angle on the circle? This Z, which means Z also 70 degree. Is it clear? So Z is also equal to 70 degree. Reason is tan-chord theorem. Tan-chord theorem. Okay? Yes. Now what is left there? You have to find the value of Y. Where is Y? Y is the angle between RPS, this angle, isn't it? And one more item is also given. What is that? R2 is 20. Where is R2? R2 is this one. Also R2 is given. What is that? 20. Clear? Alright, now we can find the value of Y. Remember, you see that PSRQ is a cyclic chord because PSRQ, those four vertices are on the circle. So it's a cyclic chord. And S and Q, they are supplementary. That is angle S plus angle Q is equal to 180 degree. What is the reason? Angles in a it's a quadrilateral, isn't it? Opposite angles are supplementary. Opposite angle of cyclic chord. Opposite angles of cyclic chord. They are supplementary, isn't it? Where S, you can calculate S plus Q is same as X, that is 60, which is equal to 180 degree. That is angle S is equal to 180 minus 60, which is going to be 120 degree. S, we got it, 120 degree. So this is going to be 120 degree. Now we can easily find the value of Y. How do you find? Look at the triangle. Which triangle? Triangle PSR, where Y we don't know, other two angles we know, that is 120 degree plus 20 degree is equal to 180. The reason is sum of angles in a triangle. Sum of angles in a triangle. Now we can easily find the value of Y. Y plus 140 is equal to 180. Therefore Y is equal to 180 minus 140, which is going to be 40. So we got it. Y value we got it. Z also we got it, and X. So this is how we are doing questions based on what? Tan-chord theorem. Okay, so this idea, please keep it in your mind when you do a full question where the tangent is there. Definitely tan-chord. We are going to do that one. Maybe in the next video we'll be doing questions, because the main theorems of grade 11 we are done. That is theorem 1 and 2. Then angles, angle at the center 2 times angle at the circle. Then cyclic chord, 2 theorems are there. Then tan-chord theorem. We are done. Then few other theorems also there. The idea is needed. You don't need to prove it. That also we'll talk about in the next video. All right. Okay. Bye.